Hello friends, welcome to my YouTube channel. In today's video, I will explain branch and bound in the subject of design and analysis of algorithms. Okay, here first we will see what is the meaning of branch and bound in design and analysis. Okay, it is used to find optimal solutions. Okay, here branch and bound is a method. It is used to find the optimal solution. What is the meaning of optimal solutions? Optimal solutions are nothing but here we will get best solutions. Here we will get best solutions like maximum profit with less cost. Okay, for example, your aim is either minimum or maximum. You have to find out the either minimum value or maximum value. In those cases, it is optimal solutions will give the best solutions. For example, if your aim is maximum to get the maximum profit, with less cost. Okay, this is the best solution. Okay, next, it is similar to backtracking. Okay, here it is similar to backtracking, but what is the difference? In backtracking, we will use DFS technology. What is the meaning of DFS technology? It is nothing but depth first search technology we will use. Okay, depth first searching. It is the depth first searching. Okay, it is what the meaning of DFS means. DFS is nothing but it is a edge based technique. It uses in stack. Okay, DFS used in stack. It is used in stack means what? It is the LIFO method. And what about branch and bounding? In branch and bounding, we will use BFS. What is the meaning of BFS means? Breadth first to search. What about it is used in breadth first search. Okay, what about here? Here it is used in BFS. It is used vertex based technology. What about vertex based technique means? It is used in Q. What is the meaning of Q? Q is nothing but it is FIFO. Okay, I will give an example. Here example diagram. A, B, C, A, B, D. Next, here C, here E, F. Okay, if you write for DFS this diagram, if you write DFS, it is what? It is the depth first search. Okay, from here it will go A, B, C. First it go for A, B, C, then D, E. Okay, then D, E, and last one is F. Okay, it will go from top to bottom. Okay, and what about same diagram for A, B, C, D, E, F. For what about this one? BFS is best first search. So A, it will go for A level. Next level is B and C. So B, C, and next level is D, E, F. So it will give D, E, F. Okay, this is the best first search. Now, okay, this is about the branch and bounding. Okay, what is the meaning of branching? A branching is nothing but it is a process of generating subproblems. It is a process of generating a subproblem. Among all of these, we have to choose which subproblem we can decide so that we will get maximum profit. Okay, here branching is nothing but we will generate the subproblems. Among those all, we have to choose which subproblem we have to decide so that to get the maximum profit. Okay, here we use state space tree diagram in the concept of this problem. Okay, among after finding, we are extending the cheapest path. Okay, very simple here. Here we use state space tree diagram. Here we will use the state space tree diagram concept in the all the problems. Among after finding, we are extending the image. Which one contains the cheapest path? Okay, where the least value available, that path will be extended. That path will be extended. Where the path is cheapest, that will be extended. That means what? The path which will give you minimum profit with less cost, that will be extended to the next level. Okay, here what is the applications of this diagram? Applications of branch and bound means the applications are traveling salesperson problem and 0 by 1 knapsack problem. Traveling salesperson problem and 0 by 1 knapsack problem. Here I am taking one example graph. This is the graph. Here it contains so many nodes, so many vertices: A, B, C, D, E, G are the vertices, and is the starting node, and is the starting vertex and ending vertex. Here we have to travel S2G travel with less cost. With less cost or low cost. How to? By using the branch and bounding. How it is possible? Okay, first we have to draw state space diagram here. Yes, here it is the S. Okay, it is the S. Here, what is the sub problems? S contains how many paths? S contains either A or B. So I am taking here A, and it is B. And what is the weight? From S to A is weight is 3. Here S to B weight is 6. Okay, which one is the least? That one has to extend it. Okay, the main point here. Which one weight is the less? That has to be extended. Here it is the 3. It is 6. So we have extended here. Again A2. How many possibilities we have? A2 we have the possibilities are A2C, A2D, A2S. So A2C, here A2, yes, again we have to go for S, and here S, A2D. Okay, here to travel S to D, what is the S to C? What is the cost here? Up to A is 3 and A to C is 7. So total cost is 10. And what about S to A is 3 and S to A is here 6. Okay, if you go backside also, it is the total cost is 6. And what about S to A is 3? Sorry, S to A is 3. And what about A to D? Here, what about A to D is 2. So what is the cost is 5. Okay, next. And what about B? Here B side also, B contains 3 possibilities: B2, D, B2E, B2S. So here I am writing B2S, B2E, here B2D, B2D. What is the cost for B2S is 12, B2E cost is 12, and B2D cost is 9. Okay, among this all sub-problems, which one is the least price? The least one is 5. So we have to expand here. Okay, so if you expand here, D2, what is the possibilities? D2A, D2G, D2E, D2B. These are the possibilities. So if you travel from D2A, what is the cost? Up to here 5, and D2A again 2. So it is 7. Okay, and D2B. Okay, if you travel D2B, what is the cost? D2B is 3. So if you are 5 plus 3 is 8. And D2E, what is the cost is? D2E is D2E is 2 and additional 2. So previously 5 plus 2 is, sorry, D2E cost is 7. And last one is D2G. Okay, what is the D2G is? D2G is 4. Previously 5. So 4 plus 9 is 9. So Here we got up to here the G, the total cost to reach G is 9 up to here. Okay, we have not completed here. Okay, we have to check any alternate values, any alternate roots. Okay, here it is G. Okay, next what I have to do? Here remaining all the nodes are less values. And what about here? This is the present value. It is the G. Okay, here we have taken. But and what about here? If you consider, yes, what will the possibilities here? S2 again A to B. Again A to B means A, B. What is the cost? A 6 plus 3 9. Again S2B is 6. So it is the 12. By comparing here G value, it is the bigger value. So it is eliminated. And what about it? It is also equal. But if you draw extending means that will become more value. So it is also not possible. And what about here? It is already more than the G value. So it is also cancelled, eliminated. And what about here? It is also eliminated. Here it is also 12. It is also eliminated. Here also D is 9. Okay. If you extend again, the value will become more. So it is also eliminated. Okay. And any other possible things here? Here A is the lesser than G value. Here B is also lesser than E, G also lesser. So we have to expand this all. Okay. If you expand A, what is the possibility here? A to C, A to D. Okay, A to C, A to D, and A to S. So here, if you are right, A to S. So what is the S value again? 3. So here 7 plus 3 is 10. So it is the over the G value. So it is also cancelled. Next B. What is the B value here? D to B. What is the value here? 3. Okay, it is also 3. So sorry. A to D. A to D value is previously 7, 2. It is the 9. So it is equal to 9. So if I am further expanded, this one is also over that. So it is also cancelled. Next, A to C, S is completed, D is completed, and C. What is the C value here? If I expand to A to C, again A to C 7. So previously 7, it is 7, it is 14. So it is also not possible. It is also not possible. And what about the possible thing here? It is B to A is 8. If you expand, B2 possibilities are B2 only possibilities are D and E. Okay, if you expand also, it is also not possible. So I am clearly closing here. Okay, and what about E? Okay, from E to G and D. Okay, E to we have 3 possibilities again. E to B is up to here E is 7. Up to here E is 7. Again, if you E to B, 7 plus 3 is 13. So it is also not possible. Again, E to D. Okay, we have possible. E to D is 2. So what is the previous value is 9. If you 2. Okay, it has to be further expanded. So it is also not possible. And E to 1. So what is the value? Previously is E value is 7. Previously E value is 7. If you add 1. So what is the value here? G is 8. Okay, previously we got the total cost to reach is 8. Now the updated value is 9. So total cost to reach G equals to 8. So what is the total cost for reach G equal to 8? Here we have to continue to find the value. Otherwise, we pick the path only. Okay, here what is the path we have to pick? Here we have to pick the path is A S2A, later A to D, S2A, later A to D, next D to E, next E to G. Okay, here what is the path here? The path is Our path is S2A to D to E to G. Okay, when all the leaf nodes weights are greater than or equal to your current cost total, then we have to stop the process. Okay, this is about the greedy general method. If you have any doubts, please ask me in comment section. All of you, please subscribe my YouTube channel. Thank you very much. Hello everyone, welcome to my YouTube channel. In today's class, I will explain traveling salesperson using branch and bounding in the subject of design and analysis of algorithm. Okay, here first if you see what is the meaning of traveling salesperson, what are the rules? Okay, here a traveling salesperson, it is a problem. Here we have to take some set of cities. The traveling salesperson has to visit each and every city at least one time, and he does not visit any city more than once. Okay, he has to visit for business purpose only one time. When you are going for a city on business purpose, you have to complete the entire task only first attempt only. Okay, if you visit again and again, means the cost will be increased. So here does not visit any city more than once. And the next one is the starting city and ending city should be same. The starting city and ending city should be same. For example, we have four cities A, B, C, D. Okay, assume these are the four cities. You are starting from A to B, and B to we visited C and C to D, and finally where is the list where is the original location A, so we have to visit A. Okay, like that we have to complete all the cities only one time. But here what is the problem here? Which path if you select, it will cover with less cost. That has to find out here. Okay, ఏ రూట్ లో మనం వెళ్తే తక్కువ ప్రైస్ లో అన్ని సిటీస్ కవర్ చేస్తాం అనేది మనం చెక్ చేయాలి. Here in traveling salesperson in branch and bound, these are the conditions. Here I am taking four cities. The four cities are A, B, C, D are the four cities, and A, B, C, D are four cities. Here I am taking the four cities values are like this. If a person A to A, if you visit at A to A means the cost is 0. A, B to B, the cost is 0. C to C cost is 0. And C to E cost is 0. Next, what is the remaining values? A to B traveling, the cost is 10. A to C traveling cost is 5. A to D traveling cost is 3. Like that, remaining all the values. Okay, now before starting the problem, here the first step is, step 1 is row reduction. Okay, here the first step is row reduction. Here what is the rules? What is the rules here to perform the row reduction? I have to check all the row or column should contains infinity, then no need to perform the reduction. Okay, all the row. Okay, here for row reduction you have to check any row. Sorry, initially we have to perform the row reduction with minimum element. Okay, here in this row, what is the minimum element is 3 is the minimum element. Here the minimum element is 7. Here the minimum element is 1. Here the minimum element is 2. Okay, with this value you have to reduce. This is the minimum element. With this minimum element value you have to reduce the row reduction. Okay, after performing row reduction, what is the value here? Infinity. 10 minus 3 is 7, 2 and 0. Here with perform the row reduction with 7. So 8 minus 7 is 1. Infinity. 9 minus 7 2. 7 minus 7 is 0. Next here 1 minus 1 is 0. 6 minus 5 infinity, and here 8. And what about here 2? 2 minus 2 is 0. Here 2 minus 3 is 1, 2 minus 8 is 6, it is infinity. So this is the row reduction value. Okay, and what is the total row reduction value? The cost is 3 plus 7 is 10, 10 plus 1 is 2, and total cost is 13. Row reduction value is 13. And step 2, column reduction. Okay, step 2 is column reduction matrix. Okay, it is row reduction matrix, it is column reduction matrix. Okay, which one I have to take? I have to take the after perform the row reduction that I have to perform. Okay, here column reduction matrix. Okay, again here column reduction matrix. Okay, what is the values here? Minimum value is, this minimum value is 1, this minimum value is, sorry, here minimum value is 0, here minimum value is 1, here minimum value is 2, here minimum value is 0. So with this value you have to perform the row reduction. Okay, what is the total value here? Total row reduction or column reduction is 3. Okay, next total column reduction is 3. So what is the final matrix? We'll get infinity. Okay, here 1 minus 7, so 6, here 2 minus 2 is 0, and here 0, 0, 0. Like that we have to calculate here 1 minus 1, 1, 0, 0, row matrix. Okay, here 1, so 6, here infinity, and what about here 1 minus 5, 4, 1 minus 1 is 0, here 2, we have to reduce to 2, 2, 0, 0, infinity, 4, here also 0, 0, 0, 8, infinity. It is the column matrix. It is the column reduction matrix. So in row reduction equals to what is the value? 13. And column reduction equals to what is the value? Column reduction equals to 3. So total reduction, what is the total reduction we have? Total reduction is 16. Total reduction is 16. Let's consider this matrix as M1. Let's consider this matrix as M1. From A, we have a chance either to go or B, or C, or D. So if we have to go in, A to B, A to C, A to D. What is the cost? We have to find out. Okay, we have to travel from A to B. A to B, we have to travel. A to C, we have to travel. A to D. So we are finding A to B, A to C, A to D first. Okay, with according to this M1 matrix. Okay, see here. Whichever path is easy or giving low cost, we have to go in that path. Okay, what is the main aim here? To find out the shortest path. So whichever will give that will go A to B to C to D. So here A to B and D value. Okay, here A value is, total reduction value is 16. Okay, we have to find out these values first. Okay, next A to B. First I am finding here A to B cost. I am finding A to B cost. Okay, when you are finding A to B cost, complete A row is infinity, comma. What is the column here? B column is infinity, and B to A path also infinity. B to A path also infinity. Remaining values from remaining values from M1. Okay, remaining values from M1. So here I am taking here infinity, A row is infinity. So infinity, 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 infinity. B column is infinity. And B to A is infinity. B to A is infinity. Remaining values are from M1. Okay, if you are taking M1 means what is the value here? 0, 0. So it is 0, 0 here, 0 here, infinity here, 8 here also 0 here, 4, it is infinity. Remaining values from M1. So after taking from M1, we got these values. Okay, see here, this is the A to B matrix. Okay, now what I have to do? The reduction of parent matrix is 16. Okay, here reduction. What is the previous reduction value? Reduction of parent matrix is equals to 16. Now we have to reduce these matrix values again. Now we have to reduce these matrix values. How to reduce? We have to check every row and column. Previously in parent matrix we have reduced column and row matrix and column matrix at a time. But here we have to check some conditions. What have to check? All the rows or column should be contained, should be infinity, then no need to check, or at least one value in row or column should be 0. Okay, at least one row or column value should be 0. So there is reduction is 0. Okay, either this condition or this condition is satisfied, then there is no reduction. So reduction is 0. So total cost of A, B is equals to cost of, this is the formula, total cost of AB is cost of parent matrix plus reduction plus A to B parent matrix. Okay. Okay. Here what is the total parent matrix cost? The cost of total parent matrix is what? 16. Here we have to check. Here this entire row is 0. So no reduction. Here 0 is available. So no. Here also 0 is available. Here also 0 is available. And here 0 is available. Here entire row column is infinity. So no need to reduction. Here also 0 is available. Here also 0. So here total matrix is, here total reduction is 0. So reduction is 0 plus A to B path value. A to B path value in parent matrix, not here. Okay, in parent matrix A to B path value is 6. So here we are taking A to B is 6. So what is the total cost here? The total cost is 22. To travel A to B, the cost is 22. So I have to update the diagram. Here parent total reduction is 16. A to B cost is 22. Like that, we have to find out A to C, and we have to find out A to C as well as A to D. Okay. For time being, I am doing this two in offline. For time being, I am doing this A to C and A to D in offline, and I will show in this video. Yeah. Now A to C. What is A to C here? In the A to C, we have to take A row is infinity values and C column as infinity values and C to A is infinity column. Okay, according to these conditions, remaining values we have to take from the M1 matrix. Okay, A row A column is infinity, all the infinities. C column is infinity and C to A is previous M1 matrix. So C to A value is infinity. So remaining all the values we have to take from the M1 matrix. Okay, after taking these values, I have to check two conditions. What? The entire row should be infinity or any value should be 0. Then there is no reduction. Here all infinities, there is no reduction. Here 0 is available, so no reduction. Here there is no all, here there is no all infinities, and also there is no 0 value. So we have to perform reduction here. Okay, what about last column? Here 0 is available, so it is also valid. Okay, what is the least value to perform the reduction? The least value is 4. With a 4 we have to do reduction. Okay, after reduction we are getting, in the place of 4 and 8 we are getting minus 4 means 0, and it is 4. It is the 4. Okay, it is the 4th. So again we have to check, after row reduction we have to check the column reduction. Here 0 is available, no need. Here also 0 is available, no need. Here also all infinities, so is okay. It is 0 is available, it is also okay. So what is the total cost value? Total cost formula is total cost equals to cost of parent plus reduction of this value plus A to C path. Okay, here what is the total cost? Parent of the total cost is 16 plus what is the total reduction here? 4 plus 0, so only 4. And what is the parent? A to C path is 0. Okay, in the M1 matrix A to C path is 0. So what is the total value is 20. Now we have to update here the A to C value is 20, and same like that we have to find out A to D. What is that? A to D. We are taking A to D means what? I have to take A to A row is infinity, D column is infinity, and D to A path is infinity. Okay, same like that we have to check all the rows. There is no here our condition is satisfying. All the infinities are either 0. Here all infinities 0. Here also 0. Here also 0. So no reduction. And what about column here also? 0 is available. 0 is available. 0 is available. Here all the infinities. So it is no end. So what is the total reduction is 0. Okay, total reduction is 0. Total cost equals to total cost of parent plus total reduction plus and D to A path. So total value is 16. So again we have to update the diagram here. A to D cost is 16. By comparing these three, okay, I am writing here A to B cost is A to C and A to D cost is, here A is 16, here up to B cost is 22, here C cost is 20 and D cost is 16. Among these subproblems, which one will get least value? We will follow the rule. Here 16 is least, so we have to travel in this path. Okay, we have to travel in this path. So we are traveling from A to D is okay. The cost is 16. And what about the remaining paths? We have to again travel D to B and D to C. We have to visit these two places. Okay. And here up to A to D is considered. A to D is considered. Okay. A to D. Okay. And what about to B? That is called A to D to C. A to D to B we have to find out. And as well as A to D. Okay. A to B is okay. A to D and up to C. These two equations again we have to find out like these methods. Like same as A to C. Like that we have to find out the A to D to B, A to D to C we have to find out. Okay, for time being I am doing on offline. Here in this diagram we are considering A to D. So A to D is least cost. So we are considering A to D path. So here what is the A to D value? That becomes as M2 matrix. That becomes as the M2 matrix. Which one is considering? That has to become as the M2 matrix. Now we have to find out A to D to B, A to D to C. Okay. See here. For A to D to B, here what you have to take? A to D to B, you have to take A row value, D row value is infinities, B column value is infinities, and B to D and B to A, those paths are the infinities. Remaining values from M2 matrix. Okay. Remaining values M2 matrix. So here A row is infinity. Okay. D row is same. A row and D row same. And B column and same. Okay. From previous same values. Sorry, all the infinities. A row, D row infinities, B column is infinity. Remaining from M2 matrix. Okay. Now we are checking for reduction, row reduction. Here all infinities, there is no. Here 0 is available, so no problem. Here also 0 is available, no problem. Here also all infinities, no problem. So what about column infinities? It is 0 is available, no problem. All infinities 0. and 0. So there is no reduction. Reduction is 0. So what is the formula here? Total cost equals to parent reduction plus D to B path. Okay, here parent is 16, 0. Here D to B is 0. So what is the total cost is 16. Okay, next. What is the second term? A to D to C. Okay, next here. A, D rows are infinities. C column is infinity and C to D and C to A is path is infinity. Remaining from M2 matrix. Okay, if you are writing like that, you will getting these values. We are checking the reduction. Okay, here all infinity, no need to reduction. Here also, here there is one value only, there is no zero. So it is reduced with one value, and it is also reduced with 4. Why? Because there is no zero. Okay, and it is okay. Okay, after reducing row reduction, infinity. Here 0, infinity. Here infinity, 0, infinity. And what about column and row reduction? There is no need to column reduction. All the satisfying. So what is the total reduction here? Total reduction is 5. Total reduction is 5. So total cost is 16 parent reduction plus here reduction is 5 and D to C path is 4. So total cost is 25. Now we completed this work. And what about the next diagram? The diagram is A, B, C, D. Okay, here B value A to B is 23. Here C value is 20. Here D value is 16. Okay, it is C value 16. Then that's why we are extended here D to B, D to C. What is the here? The cost is 16. Okay, and what about this one? Here the 25. So comparing B and C, 16 and 25. Which one is the least value? 16 is the least value. So we are extending this to find out C value. We have to find out. We travel from A to D, D to B, and D to C. So we have to find out the path for A to D to B to C. For this one, we have to find out the value. Okay. For time being, I am doing it offline. This equation, and later I will explain. Okay, here in this one, last one, where we consider, okay, where by comparing here B and C, the value is, it is the least value. So D to B value has to taking as the M3. So here it has to take M3. This matrix has to consider as M3 matrix. Why? Because here we are considering A to D to B is the least value. So we are considering this. So it becomes the M3 matrix. Now we have to calculate A to D to B, B to C. We have to calculate this one. Okay, we have to calculate this. This one means we have to take the values A, D, B. These three rows are the infinity, and C column is the infinity, and C to A path, C to D path, C to B path values are infinity. The remaining values from the M3 matrix. According to these conditions, if you write, we will get the values. The matrix values is all the infinities. So here the check the conditions to reduction. Here all the infinities. Here all the infinities. For everywhere all the infinities. So no need to reduction. So what is the reduction value is 0. And what about the total cost? The total cost equals to parent cost plus reduction plus B to C path. So 16 plus 0 plus B to C plus 0 from M3 matrix. So what is the total cost is 16. So what is the path diagram? The path diagram is here. We will apply this matrix only. Here the B to C path also 16. Okay, B to C is also 16. Now we have to travel A. Okay, next What is the path diagram? Here we have to travel A, but we won't draw the diagram for C to A. Okay, we'll write it in the directly. Okay, here what's the path diagram here? So path is A to B and D to B, B to C, and again we have to reach A. So A. So according to the matrix values, A to B value is 3. D to B value is 3. B to C value is 9 and C to A value is 1. So what is total cost? Total cost is 3 plus 3 plus 9 plus 1, that equals to 16. So according to our example, if a person has to traveling salesperson from A to B, A to D, D to B, B to C, C to A, then he will get the total cost is 16. The total cost is 16. Okay. Here, how we are writing these values means the input values. See the input values here. A to D value is 3. A to D value is 3. And D to B value is 3. So 3. And B to C value is 9. And C to A value is 1. So according to this, we have to take in these values. The total cost is 16. Okay, thank you everyone. This is about the traveling salesperson problem using branch and bound. If you have any doubts, please ask me in comment section. Please like our videos and share with your friends also. Thank you everyone. Hello everyone, welcome to my YouTube channel. In today's class, we are discussing 0 by 1 knapsack problem using least cost branch and bound. Okay, we know what is 0 by 1 knapsack problem. Till now we discussed many times this same concept in our law videos. Okay, once again I am repeating here. What is the meaning of knapsack bag? Knapsack is nothing but it is a bag or a container. Here the main objective is we have to fill the bag with more value items with less weight. Okay, very simple అండి. బ్యాగ్ లో మనం ఆ ఆబ్జెక్ట్స్ ని ఫిల్ చేయాలి. ఆ ఆబ్జెక్ట్స్ ఎలా ఫిల్ చేయాలంటే బ్యాగ్ కెపాసిటీకి మించకుండా ఎక్కువ వాల్యూ వచ్చేటట్టు మనం బ్యాగ్ లో ఐటమ్స్ ని ఫిల్ చేయాలి. ఓకే, దట్ ఈస్ ద మెయిన్ ఆబ్జెక్ట్. Here to place the objects into knapsack, so the profit is maximum. Okay, before entering to topic, first we will see here what is the meaning of knapsack. Knapsack is nothing but what? Maximum profit. It is the mainly for maximum profit. And what about here? Branch and bound. Branch is nothing but minimum profit. Okay, this is used for minimum profit. Previous talk we discussed what is the branching means minimum profit value and knapsack means maximum profit. How these two are related? These two are opposite things. Okay, so how it is useful? Okay, for that reason we will negate the values in this problem. What is the meaning of negate means? If it is positive value, we will consider as the negative values. Okay, what is the object means? To place the objects into knapsack, so the profit is maximum. Okay, here we have n objects. Each object have a profit, that is the PI value. Okay, suppose if it is 5 objects means what is the profit means? P1, P2, P3, P4, P5. And each object has the weight, that is called WI, same as W1, W2 up to W5 weights. And every knapsack problem contains a capacity of the bag. The capacity of the bag will be mentioned as M. Okay, what is the meaning of M means? Capacity of the knapsack bag. Okay, we are taking one example. What is the example here? In the example here, we are taking N equals to 4. It means 4 objects. Capacity is 15. And what are the profit values? PI is 10. If it is the first object value 10, second object value is 10, third object is 12, fourth object is 18. And what about the weights? First object weight is 2. Second object weight is 4, third object weight is 6, fourth object weight is 9. Okay, and solution is denoted by xi. The what is the xi values are 1 0 1 1. Okay, here what is the steps? Step 1. Okay, see here step 1. What is the meaning of step 1? Convert. We are already know. I already explained here. We have to negate the values. Why? Because it is the maximum profit value. It is the minimum profit value. To so we have to convert the values. Convert all the profits into negative values. Into negative values. So what is the profits here? The profits are 10, 10, 12, 18. That becomes what? Minus 10, minus 10, minus 12, minus 18. Okay. Next. What is the next step? The next step is we have to construct state space tree diagram. Okay. Now construct state space tree diagram for node 1. We have to construct state space tree for node 1. Okay, it means what? We have to construct lower bound value as well as upper bound value. Have to calculate. Calculate lower bound and upper bound value. We have to construct lower bound value and upper bound value. Okay, see here. The lower bound value will be denoted with, here the lower bound value is denoted with C cap, that is called C cap. Okay, and upper bound value is denoted with U cap. Okay, and here in the lower bound value, fraction values here assigned, accepted. Fraction value, okay, it is allowed. Okay, and what about upper bound value here? The fraction values are not allowed. Fraction values not allowed. Okay, fraction values are not allowed. What do you mean of fraction values means? If you are placing the object complete path, that is object placing, and if you want to place the object some portion of this object, that is called fraction. Okay, so here in this lower least bound we can place fraction values, and upper bound you can't place fraction values. Okay, now construct for node 1. Okay, node 1. Okay, construct for node 1. Okay, it means what? For node 1 we have to construct upper bound value, lower bound value. Okay, see here. What is the upper bound value, lower bound value? Okay, here we have to take a stack, like one stack value here. What are the first value? The first, what is the first weight? Okay, total capacity is what? Total capacity is 15. The total capacity is 15. So here, what is the first object weight? The first object weight is 2. So if you filled the first object 2, so what is the total weight becomes? The remaining weight is 13. And what is the profit of the first object? The first object profit is minus 10. So if you place the first object, we will get 10 object. 10 is the profit. And what is the remaining value? Is 13. Okay, and we can place the second object also. Second object 4. Second object weight is 4. So we are placing here 4. Okay, after placing, what is the remaining? The remaining is 9. Okay, and what is the profit for this one? This is also 10. So this is also 10 we got. Okay, next, what is the third object? The third object is 6. Okay, what is the totally balanced remaining capacity is 9. The third object capacity is 6. So we are placing 6. Okay, after placing 6, what is the pending? What is the remaining 3? Okay, what is the profit of 6 is 12. So minus 12. Okay, here we are finding for what? We are finding lower bound first. We are finding the lower bound. So lower bound what? Lower bound will be, consider fractional values are allowed. Fractional values are allowed. Okay, so what is the remaining weight here? Remaining capacity is 3. what is the total kept weight is 9. Okay, so we have to, now it is possible to fill the 9 capacity with 9 capacity weight in 3 capacity remaining, so it is not possible. So we have to take the fraction values. Okay, how to take means remaining capacity into total capacity, remaining capacity by total capacity into by what is the value of 18. So that is, what is the total value is 18. That means if you calculate, this is called, this is minus 6. So here what is the profit here? Minus 6. Okay, did you understood this one? Here first you have placed the first object is 2. So first object weight is 2. So total weight is 15. So remaining is 13. The profit is 10. The second object is weight 4. The remaining weight is 13 here. So we are placed 4. So it remaining is 9. The profit is 10. And third object is 6. Remaining is 3. And profit is 12. Then what about the least bound? When we are finding the least bound, we can consider the fractional values. So the remaining balance is 3. Available weight is 6. So it is not possible. So available weight is 9. So it is not possible. So 3 by 9 into minus 18. That equals to 6. Okay. Here we are placing the 6 profit fraction value. Okay. Like that we have to consider. Now here we have to calculate what? We have to calculate what? We have to calculate the lower bound value. Lower bound value equals to, okay, what is the profit of this all? These all profits are 10 minus 10 minus 12 minus 6. That equals to what? Minus 38. So here update the root 1 weight value is minus, least bound is C. Least bound value is minus 38. Minus 38. And what about upper bound value for road 1? Upper bound, that equals to what? U cap. That is called U cap. Here don't forget, here C cap means lower bound value and U cap means upper bound value. Same diagram here also. Okay, same. Okay, what is the difference between lower and upper bound value? Lower bound value in fraction values will be allowed, but here no fraction values. So no fraction values means what? Same, 2, 4, 6. It means 3, 9, 13. Here what is the weight? 10, 10, 12. Okay, that's it. Okay, what is the profit here? Minus 32. So what is the upper bound value here? Minus 32. Okay, minus 32. Okay, same like that, we have to draw this state space T diagram. Okay, here first one is minus 32. Okay, see here I am writing here again. Here I am drawing the table diagram here. 1. What is the lower bound value here? The lower bound value is C cap equals to minus 38. U cap equals to minus 32. U cap is minus 32. Now we have to expand this diagram. Now we have to expand. Okay. Now we are expanding means what? How to expand? Okay. If you expand 1, the remaining nodes are 2. Here 3. Here it is 3. Okay. Here 3. Okay. And again here x1 equals to 1 is considered. x2 equals to, x1 equals to 0. And here x1 is not considered. Okay. Like that we have to consider the again same values. Okay. For node 2, we have to consider lower bound value, upper bound value. Okay, here what is the lower bound value? Lower bound value, it means what? x1 equals to 1. x1 equals to 1 means 1 has to be considered. Here the first object is considering. Remaining objects also automatically x1 equals to 1 is considering means 2 is also considering and third is also considering. And what about fourth? That is lower bound, the fraction values will be considered. So the values are same as previous value. So I am not doing here. Here what is the least bound value is minus 10, minus 12, minus 10, minus 6. So what is the total here? Minus 38. Okay, for x1 equals to 0. Okay, x1 equals to 1. And what about upper bound value? X1 equals to 0. Here it is considering means 2, not considering 3. So here not considering. Okay, what is not considering means here also same values. Here also same values. Previously for 1, previously one when we did one. Okay, sorry here least bound value is what? Least bound value is minus 38. And what about upper bound value? Upper bound value is what? X1 equals to 1 has to be considered. So the upper bound value is same 32. Upper bound value is 32. For every node, we have to calculate least bound value, upper bound value. Here, the same values will come as the previous value. Okay, and what about x3? 3 equals to what? x1 equals to 0. x1 equals to 0 means we are not considering first object. So, we have to calculate the node 3. We have to calculate for node 3. Node 3 equals to, okay, node 3 equals to, again, what I have to find out here? Least bound value, upper bound value have to calculate. Least bound means what? Least bound value for 3. Okay, least bound value for 3 means, okay, same like that here also. The first object is not considering. Okay, x1 equals to 0. That means first object is not considering here. Okay, not considering means what? Okay, it's for lower bound value. Sorry, C cap, and it means lower bound value. Finding the lower bound value. X1 equals to 0. It means we have to take. Okay, what is the capacity here? Capacity is 15. Okay, what is the x1 value equals to 0 means first object is not considering. What is the first object value? The first object value is 0. So not considering. The second object value is 4. Okay, and what is the remaining here? 9. Remaining is 9. What is the profit is 10. And what is the third object is 6. The remaining is 5. Here also the profit is 12. And fourth object is, the fourth object weight is 9. The balance is 5. So how it is calculated? 5 remaining by total weight into total profit. If we calculate this one, what we will get here? 9 1 jar, 9 2 jar, that equals to minus 10. So profit is minus 10. So calculate lower bound value equals to minus 10, minus 12, minus 10. That equals to minus 32. Here C cap value is minus 32. C cap value is minus 32. And upper bound value. Okay, for this one only, upper bound value for node 3, upper bound value is, okay, here also x3 1 equals to not equals to 0. Okay, here x1 equals to not equals to 0 means what? Again, what is the difference between lower bound value and upper bound value? The same like will appear here, but what is the difference here? Here fraction values is allowed, here not allowed. So what is the profit? 4 minus 10. Here 6 minus 12. And what about remaining? Remaining is not possible. Remaining is not possible. So upper bound value equals to minus 22. 10 plus 12 is minus 22. So update the diagram here. Upper bound value is minus 22. Okay. Here which is the least bound value? Which is the least bound value is lesser value, then that side will be extended. Here the diagram branch has to be extends either 2 node or 3 node. Which side will be have to extended? The least bound value. Okay, here least bound value is smaller value. Which side least bound value is smaller, then that side will be, the diagram will be extended. Here 2 node contains the minus 38, 3 node contains the minus 32. Which one is the least value here? By comparing minus 38 and minus 32, this is the least value. Okay, here the minus value, so it is the least value. So we have to extend this one. Okay, here it is the least value, so we have to extend this one. Okay, if you are extending this one, what? If we are extending this, we will get 4 5. Okay, 4, 5. 4 and 5. Okay, here what is the value? X2 equals to 1, x2 equals to 0. We have to take x2 equals to 1, x3 equals to 0. For time being, I am writing values directly in offline mode. Please wait. For note 4, I am doing here. What is the note 4 value? For note 4, this is the x2 equals to 1. Okay, if you check the first node also, we are consider x2 value. So the same values will become here. Lower bound value is for node 4. Lower bound value is minus 38 and upper bound value is minus 32. And what about node 5? For node 5, what is the node 5? The node 5 is nothing but here x2 equals to 0. And x2 we are not considering x2 value. So we have to find out lower bound value. What is the lower bound value for this one? Lower bound value is again x2. x2 equals to 0 means we are not considering the second object. So first object value is 2. So minus 10. The second object is not considering. Third object is 6. So 13 plus 6 means 7. So that value is 12. And remaining is 7 by 9 into 18. So what is the value? So 14. So what is the total lower cost value? Minus 12 minus 10, 12 minus 14. That equals to minus 36. So least bound value is minus 36. Okay. Here least bound value is for 5. Least bound value is minus 38. For upper bound value is minus 32. And what about 5? Least bound value is minus 36. And what about upper bound value for capital? Here same diagram. Here we are not considering the fraction value. So the diagram contains what? 2, 6. So 10 minus 12. So what is the total? Minus 22. Minus 22. So what is the upper bound value here? Upper bound value equals to minus 22. Okay. By comparing these two, which one is the least value? The least value is here. By comparing these two upper bound values, what is the by comparing these two, which one is the least value? Least common value is minus 36 minus 38. So it is the least value. So we have to extend. Okay, I have to extend means if I extend this one, we will get 6 and we will get 7. Okay, 6 and 7. Okay, what about here? X2 equals to 1. Here x3 equals to 1. Here x3 equals to 0. We have to again we have to find out the least bound value, upper bound value. Here also least bound value, upper bound value. Okay, again how to calculate? Again the same procedure like this. Same procedure like this. We have to calculate for node 6 and 7. For time being I am doing on offline. I will explain. Okay, now check. Here actually I forgot to tell one thing. Here how which node has to extend means we have to extend. We need to check for every node upper bound which one is the least, then that node will be explored. Either in second and 3, which node upper bound is least, that one will be extends for explored further. Here upper bound value is minus 32. Here upper bound value is minus 22. Which one is the high least? So it is the least value. So we are expanding this node. So by expanding. Okay, again here for 2 from 2, 4 and 5 came. Here upper bound value is minus 32. Here upper bound value is minus 32. So it is the least value. It is the least value. So expanding this one. Okay, again for 4 and from 4 we are getting what? We are getting 6 and 7. Okay, how to calculate 6 and 7? Here x3 equals to 1. Here x3 equals to 0. Okay, by comparing here x3 equals to 1 means the first object is considering, here not considering. Okay, for 6 I am calculating here x3 equals to 1. It means the same value. For 1 we did x3 equals to 1. For 2 we did x3 equals to 1. For 3 also we did x3 equals to 1. For 1 we did for 1 we consider x3 equals to 1. For 2 also we did x3 equals to 1. 4 also x3 equals to 1. So the same as the node 1, 2, 3, 4 values. So the least bound value is minus 38, upper bound value is minus 32. Okay, from 6. Okay, and what about 7? We have updated the values minus 38, minus 32. For 7, least bound value and upper bound value. How to calculate? X3 equals to 0. It means we are not consider the x3 equals to 0. x3 equals not equals to 0 means what? x1 equals to 1, x2 equals to 1, x4 equals to 1. Okay, so here if any place available, x4 equals to also 1. So the first object is placed in 2, remaining 13. Second object placed in 4, the remaining 9, and third object weight is 9. Fourth object weight is 9. So the remaining weight becomes to 0. So we are total capacity 15. We filled 1, 2, 4 objects. So what is the total cost here? 10, 10 minus 8. Total cost is minus 38. Least cost value is least board value is minus 38. And what about upper board value? There is no fraction value. So upper bound values are same value. So 2, 4, 9. So that is a minus 38. I have 7 values here in the diagram, 38 and 38. By comparing and 6, 7, 7, which upper bound value is least? Which upper bound value is least? By comparing 6 and 7, which upper bound value is least? Here upper bound value is minus 32. Here upper bound value is minus 38. By comparing these two, which one is the least? This is the least value. So we are expanding this 7, expanding 7. So expanding 7 means what we will get? 8 and 9. So what is the 8 value? Here x3 equals to 1, x3 equals to 0. Here x4 equals to 1. Here x4 equals to 0. Okay, if you are expanding, x4 equals to 1 means we will get 8. x4 equals to 0 means 9. Okay, what is the least bound value? Here 8, the least bound value. What is the least bound value here? x4 equals to 1. It means we have to consider the fourth value. We have to consider the fourth value means what? Okay, see here. Here x1 equals to 1 is considering, x2 equals to 1 is considering. In here x3 equals to 0. 3 is not considering. x4 equals to 1 has to be considered. Okay, for 8. So x1 equals to 1, x2 equals to 1, x3 equals to 0, x4 equals to 1. So we are considering total capacity 15. So first object 2. So second object 4. Third object is 9. So total is 15. So the weight 10, 10, 18. So total weight, least cost weight is 38. So total least cost weight is 38. And what about the upper bound value? No fraction values will be considered. Here there is no fraction values means same values 2, 4, 9. So that is the minus 10, minus 10, minus 18. So what is the total value? Upper bound value is minus 38. The upper bound, for node 8, upper bound value is minus 38. So I am updating here 8 value is minus 38. Here also minus 38. And what about ninth value? Ninth node value. For ninth node value, what is the values here? We have to take diagram. x1 equals to 1, x2 equals to 1, x3 equals to 0, x4 equals to 0. So we have to take only first object and second object. So x1 equals to 1, x2 equals to 1, x3 equals to 0, x4 equals to 0. So for least bound value, first object is considering 2, second object is considering 4. The total weight is minus 20. And what is the difference between upper bound value? Upper bound value is the same, but there is no fraction values. Here there is no fraction value. So the same diagram 2, 4, and what 10 and 10. So what is the upper bound value here? 20. Here we have to take upper bound value is 20, least bound value is 20. Okay. Then what is the diagram here? We have to compare here least upper bound value, here least upper bound value, upper bound value, upper bound value, which is the least is the least value, is the least value. Further, there is no objects to place. So what is the least upper bound value here? We got 38. So what is the solution? So the solution is what? What is the solution here? Here we have, so solution vector x1, x2, x3, x4. Okay, what is x1 value? 1, x3 value is 1, x2 value is 1, x3 value is 0, 1. Okay, what is the profits? The profit is first object is 10, second object is 10, and third object is 0, and fourth object is 18. So here we are not mentioned any value. So what is the total profit is? Total profit is minus 38. Minus 38. Negate value. Minus 38 negates is simply that equals to 38. So the total profit is plus 38. The total profit is plus 38. Okay, if you fill the knapsack bag like first object, second object and fourth object, you will get the profit is 38. Okay, this is about the knapsack problem using least bound and least branch and bound. Okay, if you have any doubts, please ask me in comment section. Please like our YouTube channel. Please subscribe our YouTube channel. Share with your friends. Thank you, everyone. Welcome to my YouTube channel. Concept clear. In today's class, we will discuss about 0 by 1 knapsack using FIFO branch and bound. Okay, in previous topic also 0 by 1 knapsack problem using branch and bound. Here FIFO branch and bound. That is the difference is FIFO branch and bound. Okay, here what is the concept here? It is same as 0 by 1 knapsack least to cost branch and bound problem only. But here what is the difference here? But it has one global upper bound value. Here it has one global upper bound variable. Okay, it contains the global upper bound variable. Okay, that is the difference. Remaining all are same concept like 0 by 1 knapsack bound, 0 by knapsack using branch and bound. Okay, LBCC. Okay, it is same. Okay, what is the difference here? It contains global upper bound value. Okay, here what is the aim? The aim is to fill the objects in the knapsack with maximum profit. Same like that in the previous topic, in the last units also we discussed. What is the knapsack problem? Main aim is fill the knapsack bag with maximum profits with least cost, with less cost or less cost. Okay, and what is the solution here? Here solution vector xi equals to x1 comma x2 comma x3 comma x4 equals to 1 0 1 1 1 0 1 1. State space diagram is for each node have to construct. Okay, it is also same as previous topic. And what about here? Here for each node have to construct lower bound value, upper bound value. And what about least cost value? Least cost value, the fraction values are allowed. And what about upper bound value? Fraction values are not allowed. Okay, here fraction values are allowed. Here fraction values are not allowed. Then what is the difference between previous topics? Here we have two conditions. What are the two conditions mean? The first one is in global upper bound is root or starting node. Okay, which one has to take the global upper bound value means the root element or starting element is the global upper bound value. Global upper bound value will be placed. Okay, global upper bound value, what is the value means? What is the root element or starting node? That element's upper bound value is taken as this global upper bound value. Okay, after that calculating upper bound value for each node. Okay, after that calculating upper bound value for each node, this upper bound value will be compared with global upper bound value. Okay, suppose global upper bound value is smallest, then no need to change. Otherwise, we have to swap the global upper bound value with upper bound value of any node. Okay, ఏ నోడ్ కి అయితే upper bound value అనేది smallest గా ఉంటుందో ఆ వాల్యూ తోటి global upper bound value will be swapping. Okay, if global upper bound value is smallest, then no need to change. Else we have to change global upper bound value with which node upper bound value is less. Okay, that value has to be swapped. Okay, next, what is the second condition? If global upper bound value is greater than least upper bound value is greater than global upper bound value, then kill that node. What is the second condition is lower bound value lower bound value greater than global upper bound value, then kill that node. These are the two conditions we have to follow in this problem. These are the two conditions. What is the first condition? Global upper bound value will be compared with upper bound value for every node. Okay, if it is smaller, then we have to swap the value. What is the second condition? If lower bound is greater than global upper bound value, then kill that node for every time. Okay, these two are the conditions. Remaining are the same as the previous topics. Here also we have to we are taking one example. Okay, it is the same problem, so I am taking the same example values, and we have to consider the same. What do we have to consider? We have to consider the same state space tree diagram. Okay, I am taking the values are I am taking the same example values. Capacity is 15, P1, P2, P3, P4, 10, 12, 12, 18. W1, W2, W3, W4 is 2, 4, 6, 5. First, what I have to take? First, here also we have to navigate. We have to negate the profit values. To negate the profit values, that means what? 10 becomes minus 10, 10 minus 10, 10, 12 minus 12, 18 is minus 18. We are negating the values. Okay. After that, for first node, we have to calculate what? For node 1, we have to calculate lower bound value. How to calculate the lower bound value? Same diagram, same as previously. Okay, total capacity is 15. First object is 2. So pending is 13. Second object is 4. The pending is 9. Third object is 6. The pending is 5. Sorry, pending is 3. Okay, and what about here? Minus 10, here minus 10, here minus 12. Here it is not possible to fill the entire, so minus 3 into 9 minus 18. If you calculate this one, 2, so total is 6. So here 6 is completed. So lower bound value equals to minus 38. Minus 38. And what about upper bound value? Upper bound value is U cap. And U cap means what? What is the difference between these two? Fraction values are not considered in upper bound value. So without fraction values, 2, 4, 6. So 10, 10, 12. So what is the upper bound value here? Minus 32. Okay, now we consider the root node. What is the root node? Is starting node is the root node. So 1 is the starting node. So C cap value and U cap value. What is the C cap value here? Minus 38. What is the U cap value? Minus 32. Okay, here what I have to take? Global upper bound value equals to what? Root node upper bound value. Here what is the root node upper bound value? Root node upper bound value is 32. So it is minus 32. Okay, that is the first condition. And what is the second condition? Here lower bound value greater than GUB. Check చేసుకోవాలి. We have to check for next time. Then kill the node. Kill node. Okay, then we have to kill the node. Now what you have to do after constructing first root node, then we have to construct second one. Okay, you have expanding this one. Expanding this one. Here x1 equals to 0. Here x1 equals to here x1 equals to 1. Here x1 equals to 0. Okay, here x1 equals to 1 means what? X1 equals to 1 means that becomes 2. It is 3. Again, for this 2 we have to find out lower bound value, upper bound value. Here also lower bound value, upper bound value. Same as previous method. Same as previous method. For calculating, I am doing in a separate page. Okay, don't confuse here. For lower bound value, for second node, node 2, lower bound value x1 equals to 1. Okay, x1 equals to 1 means what? We have to consider x1 equals to 1. Here also we consider x1 equals to 1. So same values as previous one. So upper bound value is what is the value? Minus 38. Okay, lower bound value is minus 38 and upper bound value is minus 32. Minus 32. And what about node 3? Node 3, we are updating here minus 38, here minus 32. Here node 3 equals to what? x1 equals to 0. So here x1 equals to 0 means x1 value is not considering 0. Sorry, x1 value is not considering. x1 value is not considering means what? What is the lower bound value? Lower bound value equals to first value is not considering means the second value. What is the second value? 4, 6. What is the profit? 10, 12. Here 4 means 11. Here 5. And what is the balance here? 5 by 9 into minus 18. That equals to what is the value? What is the value here? We will get 10. Okay. So what is the total profit here? Lower bound value is minus 10, minus 12, minus that equals to minus 32. Okay. Minus 32. And that is the lower bound value is minus 32. And what about upper bound value? That equals to same diagram I have to consider. Here the fractional values are not considering. So 4, 6, so 10, 12. That equals to minus 22. So upper bound value is minus 22. So update these values here. Here lower bound least value is minus 32. Upper bound value is minus 22. Which one has to be extended? Which one has to extend? Before extending, we have to check. It is not global value is 32. Upper bound value is 32. So no need to change. No need to change the global upper bound value. And what about here? Upper bound value is 22. Here upper bound value is minus 32. Which one is the least? That is the least. So no need to do. And the second condition, least bound value minus 38 is greater than upper bound value. Global upper bound value? No. So it is not, no need to change. And here also no need to change. So we have to expand this here each node. Here we have to expand x1 equals to x2 equals to 1. Here x2 equals to 0. If you expand this one, we will get 4. If you expand here 5. And the same as here also at the same level. So x2 equals to 1. Here it is 6. It is 7. Here x2 equals to 0. We have to calculate for lower bound value, upper bound value. Here also lower bound value, upper bound value. Here also lower bound value, upper bound value. Lower bound value, upper bound value we have to calculate. Okay, for time being I am calculating these values directly. I am writing here directly values, and I will explain what is the concept here. Here the fourth one we will get minus 38. Okay, how to calculate? It means same procedure. Okay, don't confuse. Minus 38. Here minus 32. Here also minus 36. Here minus 22. Here minus 32. Here minus 22. Here minus 30. Here also minus 30. Now check here. Okay, here for this upper bound value minus 32. Here also minus 32. No need to change. Here least value minus 38. Here also minus 38. There is no need to change. Here also same. Here also, sorry, actually here fifth node. Okay, here fifth node. What is the fifth node here? The fifth node is x2 equals to 0. Here upper bound value is minus 22. Here also minus 38. Then no need to change. What is the second condition? Least bound value is minus 36. Here least bound value is, what is the least bound value? Minus 32. Which one is the least value? This is the least value. So kill this node. So kill this node. How are you killing here? Minus 36 greater than minus 38. Okay, minus actually forget this part. After 4 we have to expand. After 4 we have to expand this one to 8, this one to 9. Okay, here lower bound value, upper bound value. Lower bound value is minus 38, upper bound value is minus 32. And what about here? Lower bound value is minus 38, upper bound value is minus 38. Okay, now we are doing here upper bound value is okay, it is okay. And what about here? Here upper bound value is minus 38 and minus 32. So I have to change the upper bound value into minus 38. So it becomes minus 38. Okay, now sorry, here it is not. So actually here not at 8th node. Here at 9th node. Here upper bound value is minus 38. Here least bound value is minus 32. Minus 38 greater than minus 2. So update. So update the upper bound value to minus 38. Okay, minus 38 to update. Okay, next. What is the fifth node? Here here the upper bound least bound value is minus 36. Global upper bound value is minus 38. So that is the condition is true. So we are killing the fifth node. Killing the fifth node. And what about the sixth node? The sixth node also. What is the upper bound value here? Minus 32 greater than minus 38. So we have to kill this node also. Kill this node. And what about this one also? Here minus 30 least bound value is minus 30 greater than minus 38. So it is also killing. It is also killing. Next one. What about the ninth? For 8th we are expanding. If we are expanding 8th node, we are getting what are the values here? 9, 10 and 11. We are expanding these two also. We will get 12 and 13. 12 and 13. Okay. Here it is x3 equals to 1. Here it is equals x3 equals to 0. And what about here? x4 equals to 1. x4 equals to 0. Here x4 equals to 1. x4 equals to 0. Same. Least bound value, upper bound value. 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 Okay, we have to calculate these values. Okay, for time being, I am writing directly. Okay, same procedure as the previous, like this. We have to find out calculate the values. Here upper bound value. Here least bound value is the least bound value is it is not possible. Why? Because here x4 equals to 1. x4 equals to 1 means what? x1 equals to 1, x2 equals to 1, x3 equals to 1, x4 equals to 1. It means here x4 should be placed mandatory. Okay, x4 equals to 1 means it should be placed. But before values are what? x1 will be filled, x2 is filled, x3 equals also filled. It is possible? It is not possible. So it is infeasible. Okay, it is infeasible. The 10th node is infeasible. Okay, and what about 9th node? It is possible. Why? Because it is x1 equals to 1, x2 equals to 1, x3 equals to 1, x4 equals to 0. It is possible. Okay, if what are the values here we will get? Here we will get minus 32. Here also minus 32. Okay, and what about 12th node? 12th node contains minus 38. Here minus 38. Here we will get minus 20, minus 20. Okay, now check the conditions. Here upper bound value is minus 32 and the global upper bound value is minus 38. So what is the second condition? Minus 32 greater than minus 38. The condition is true. So what? Kill 11th node. Kill 11th node. Okay. Next. What about these two? Here everything is fine. Here the upper bound value is 38. Least bound value is 38. Here upper bound value is 38. Here least upper bound global upper bound value is 38. So no need to do. Here also. Here least bound value is 20 greater than minus 38. So condition is true. So kill 13th node. Kill 13th node. And what about the only node we have? 12th node is pending. So what is the solution here? Minus 38. Upper bound value is minus 38. So what is the solution for this one? So solution is 1. Okay, why it is 1 means x1 equals to, check here, x1 equals to 1. So it is the path, x1 equals to 1. Then to reach 4, x2 equals to 1. Then x3 equals to 0. Then x4 equals to 1. So what is the solution? x1 equals to 1, x2 equals to 1, x3 equals to 0, x4 equals to 1. So what is the profit here? Minus 10, here minus 10, here minus 18. Total profit is minus 38. Okay, negate plus 38. So when the change plus 38. Okay, this is the total profit. Okay, if you use FIFO and branching also, we are getting minus plus 38. Sorry, plus 38. Okay, here what is the note point here? When we change global upper bound value, then which nodes are not explored? Those nodes ALB will be compared. Okay, ఇక్కడ మీకు చెప్పేది చూసారా, 4th ను ఎక్స్పాండ్ చేసినప్పుడు అప్పటి వరకు మనం 5th ని ఎక్స్పాండ్ చేయలేదు. సో అగైన్ ద కండిషన్ అనేది మళ్ళీ చెక్ చేసుకోవాల్సి వస్తుంది. ఓకే, ఇక్కడ మీరు ఇక్కడికి వచ్చారు సార్, 8, 9 చేశారు, తర్వాత 5, 6, 7కి వెళ్ళారు అని అంటే ఇక్కడ నోట్ పాయింట్ ఏంటంటే వెన్ వి చేంజ్ గ్లోబల్ అప్పర్ బౌండ్ వాల్యూ దెన్ విచ్ నోట్స్ ఆర్ నాట్ ఎక్స్ప్లోర్డ్, అంటే ఏ నోట్స్ అయితే ఎక్స్టెండ్ కాకుండా ఉంటాయో ఆ కండిషన్ ని మళ్ళీ మనం చెక్ చేయాల్సి వస్తుంది. ఓకే, దట్స్ వై వీఆర్ కంపేర్డ్ 5, 6 and 7. 5 and 6 are terminated. Okay, this is the key point for this topic. Okay, don't confuse. If you have any doubts in our topic, please ask me in comment section. I will explain, I will respond your doubts. Okay, please like and share, subscribe our YouTube channel for more videos. Thank you everyone. Hello everyone, welcome to my YouTube channel. In today's class I am explaining P, NP, NP complete and NP hard problems in the subject of design and analysis of algorithms. Okay, first of all, what is NP, what is P? Okay, here P is nothing but polynomial time, NP is non-deterministic polynomial time. Okay, P is polynomial time and NP is non-deterministic polynomial time. Okay, first, what is the meaning of P problem? Okay, here P is nothing but if a problem can be solved in polynomial time, then it is called P problem. Suppose if you take any problem, that problem is solved in given polynomial time, then it is called P problem. Then it is called P problem. Okay, same as what is the meaning of non-deterministic polynomial time means NP problem. If a problem which cannot solved in polynomial time, then it is called NP problem. Okay, if it is solved, that is polynomial time. If it is not solved, that is called non-deterministic polynomial time. Depending on computing time, algorithms can be divided into 2 types. What are the 2 types means? Algorithm, first one is polynomial time algorithm, second one is the exponential time algorithms. Okay, here which algorithm takes less time to compute the task is known as polynomial time. Okay, if any algorithm takes very less time, okay, to compute the process, those algorithms are called polynomial time algorithms. Those algorithms are called polynomial time algorithms. And what about exponential times? Okay, if any algorithm takes more time to complete, okay, if any algorithm takes more time to complete the task or execution of the process, then those are called exponential time algorithms. Those are called exponential time algorithms. For example, for polynomial times are binary search algorithm. Binary search algorithm, what is the time complexity? Log n. And what about linear search? The time complexity is n. Okay, similarly, if you take exponential time algorithms are the examples are zero wave NASDAQ problem. The time complexity is 2 power n, and the traveling salesperson time complexity is also 2 power n. Okay, okay, these are the polynomial time. These are the exponential time. What is the difference? If that algorithm executes in a given time, that is called polynomial time algorithms. If it is take more time, then it is called exponential time algorithm. Okay, problems which cannot be solved in polynomial time can be classified again into 2 types. Okay, problems which are not solved in polynomial time. That means what? Exponential time algorithms are again classified into two types. First one is NP complete, second one is the NP hard. What is meaning of NP complete? What is meaning of NP hard means? Okay, see here. NP complete. What do you mean of NP complete means? If one NP complete problem solved in polynomial time, then all other NP complete problems are solved in polynomial time. That is called NP complete problem. If any one NP complete problem is solved in a polynomial time, then remaining all the NP problems are also completed in given polynomial time. Okay, what is the second one? NP hard. What do you mean of NP hard means? If one NP hard problem solved in a polynomial time, then other NP problems can be solved in polynomial time. Okay, if one NP hard problem solved in polynomial time, then all other NP problems can be solved in polynomial time. This is about NP hard and NP complete. Okay, we will see here. What is meaning of NP? What is meaning of NP? What is the graph? Okay, here we will see this is the N, this is the P, this is the P, and what is the NP? This is the NP hard. This is the P, and remaining are the NP. Okay, assume here this is the P, and this is the NP, and this is the NP hard. Okay, in between where the two circles are touching, this part is called NP complete. This part is called NP complete. We will see what is the definition for NP complete means. A problem is called NP complete if the problem is what? If the problem P is in NP, P here P is inside the NP. Am I correct? So the condition is true. And P is in NP hard. Here P is also part of the NP hard. Okay, when these two properties are satisfying, then the problems are called NP complete problem. NP complete problem. Okay, problems which are in NP hard as well as NP hard is known as NP complete problem. Okay, see here, problems which are in NP as well as NP hard is known as NP complete. Okay, చూడండి ఇక్కడ here NP problem లో ఉన్న problems as well as NP hard ఉన్న problems. It means what? Where the two circles are touching, this part is called what? NP complete problem. NP complete problem. All NP problems that can be reduced to set the given time is known as NP hard problem. All the NP problems that can be reduced to set with given time is known as NP hard problem. Okay, this is about introduction about this is about the introduction about the P problem, NP problem, NP complete and NP hard problems. If you have any doubts, please ask me in comment section. Okay, please like our videos and subscribe our YouTube channel. Thank you everyone. Hello everyone, welcome to my YouTube channel. In today's class, I am explaining non-deterministic algorithms. What is the meaning of non-deterministic algorithm? Means in deterministic algorithm, the outcome of the algorithm is fixed. Okay, generally if you take any deterministic algorithms, the outcome is fixed. Okay, for example, searching algorithm. What is the searching algorithm? If you are searching algorithm is nothing but you are searching a particular element or a key. Okay, if you are set the same algorithm for number of times also, if the key is same, then the result also same. Okay, if the result also same, if the key is found, it will display the required item is exist, the output will be true, else it returns the false. Okay, here non-deterministic algorithm, it is used to reduce the time complexity. The time complexity we use in non-deterministic algorithm. When you want to reduce the time complexity, in those cases we will use the non-deterministic algorithms. To reduce the time complexity, we use non-deterministic algorithms. Okay, the outcome of non-deterministic algorithms will be restricted to specify set of the possibilities. We restricted to specify set of the possibility. That means having some set of outputs. Out of them, output will become. Okay, there is a predefined set of results. In those, any one output will be displayed. Okay, To specify such algorithms, we introduce three functions. What are the three functions? Means choice function, failure and success. Choice, failure and success. Here, what is the meaning of choice? Arbitrarily chooses one element from the set S. Okay, choices means it will choose the one element from the given set. And failure, it is a signals, and it is a signals when the problem is unsuccessful. In those cases, it produces the signal like unsuccessful solution. And the last one is successful function. What is the meaning of successful function? Generally, when the problem is successfully executed, then it raises the signals like successful solution. Successful solution. Here we will see one example problem for non-deterministic algorithm. Here, what is the problem here? Searching. Here the example is searching x on a of 1 to n range. Here the 1 to n is range. Here and here n greater than or equals to 1, and successful returns j if a of j equals to x or returns the o otherwise. Okay, here what is the meaning here? A of j is nothing but what? It is a searching algorithm. We are searching x on a. Okay, in this problem we are searching x on a array. Okay, on successful it returns the j, else it returns the 0. Okay, first what is the step? J equals to choice of what we are searching here, 1 to n. J equals to choice of 1 to n. It means in deterministic looping is available. In deterministic looping is available. Okay, if a of j equals to a of j double equals to x, and it means you are comparing here. Then if the condition is true, then write j. Okay, if it is the condition is true, it means what? J is found. Okay, then write j. Write j means we are printing the output is j. Okay, when the successful function. If true, okay, this message will be printed when the condition is true. Else, write off 0. Write off 0 means what? It is failure message. Okay, it is very simple problem, not deterministic algorithm. Okay. If you have any doubts, please ask me in comment section. Thank you everyone. Please like or subscribe our YouTube channel. Thank you. Hello everyone, welcome to my YouTube channel. In today's class, we will discuss a small topic, deterministic algorithm and non-deterministic algorithm differences. This is the question asked a number of times in various public examinations. Okay. Here, what do you mean of deterministic algorithm? Deterministic algorithm is nothing but a problem is in a given particular input, the computer will be give always the same output. Given a particular input, if you give any particular input, it gives the always give the same output. Okay, that is the deterministic algorithm. Second, not deterministic algorithm. Here, what is the example for this one? If you are given q naught, okay, if you have 0 and 1 is input, means if you are give 0, the output is q of 1. Okay, if you give 1 means the output is q of 2. For every time you give the same inputs, we use the same outputs. And what about is non-deterministic means? In this case, the computer did not understood what is the actual output. Okay, if you give q naught, for q naught, if you give 0, one time it will return the q1. Yeah, another time if you give the 0 and it returns the q2. Okay, here if you give the same input value also, but it will produce the different output. Here the input data will be not understood by the computers. Okay, the third point is deterministic algorithm can solve the problem in polynomial time. Okay, deterministic algorithm is nothing but if a problem is solved in given polynomial time, that is called deterministic algorithm. Okay, what is the meaning of non-deterministic algorithm? We already discussed it previously. Non-deterministic algorithms can't solve the problems in given polynomial time. It is not solve the problem in given polynomial time. Okay, listen. Next, the last point is can determine what is the next step. Okay, in deterministic algorithm, we can also determine what is the next step, next upcoming step. Okay, and what about is non-deterministic algorithm? We can't determine what is the next step. Okay, this is about the differences between deterministic algorithm and non-deterministic algorithm. If you have any doubts, please ask me in comment section. Please like or subscribe our YouTube channel. Thank you everyone. Hello everyone, welcome to my YouTube channel. In today's class, we will discuss about Cook's theorem. Okay, Cook's theorem in the subject of design and analysis of algorithms. Okay, here what is the statement? Here the statement is the scientist Stephen Cook in 1971 stated that satisfiability problem is a NP complete. Okay, satisfiability is a problem in NP complete. Okay, here Cook's theorem states that satisfiability is in P if P equals to NP. Okay, this is the problem statement. Okay, here we have to prove so that the satisfiability we are considering as the SAT. Okay, problem is NP complete. Okay, how we are proving? Here SAT is in NP because a non-deterministic algorithm can guess an assignment of truth value of variables. An expression is satisfiable if it is the take true. Okay, very simple. ఈ టాపిక్ మొత్తం కూడా ఏంటంటే థియరీ టాపిక్. these are the theory points. We have to write these points in the exam also. Okay, next SAT is in NP complete such that the SAT ENP and any NP problem can be reduced to SAT. So SAT is NP hard. So SAT is NP hard. The non-deterministic algorithm also determines the value of expression for corresponding assignment and accept the entire expression is true. Okay, next point. The algorithm is composed of an input tape where tape is divided into a finite number of cells. Next point. Each cell contains only symbol at a time. Each cell contains only symbol at a time. Okay, next point. The read or write head which reads each symbol of the cell. The computations is performed in number of states. The last point is the algorithm terminates when it reaches the actual state. Okay, actual state. Okay, this is about the Cook's theorem. This is the totally some set of statements. Okay, this is the Cook's theorem. Okay, all of you check these points. You have to write these points only in the examination. Okay, there is no derivation part. Okay, thank you everyone. If you like my videos, please subscribe my YouTube channel. If you have any doubts, please ask me in the comment section. Thank you everyone.